Hi everyone, I'm Aidan O'Sullivan, Associate Professor in Energy and Artificial Intelligence at UCL Energy Institute, where I lead the Energy Systems and Artificial Intelligence Lab. So today I'm going to talk to you about the intersection of two powerful trends, energy security and AI. So what connects these two images? So on the left we have the Straits of Hormuz, a 20-mile gap between the Gulf of Oman and Gulf of Persia, through which 20% of global liquid natural gas supplies flows and 25% of seaborne petroleum flows. And on the right, we have a modern data center, hyperscale data center used for training AI. So what is the connection between these two? Well, energy. So the largest source of energy demand, or fastest growing in the world, is hyperscale data centers. So what you see in this image is a graph of the projected power growth for training one frontier model. So this is the energy required for the training process that gives you Claude or Gemini or ChatGPT. And as we go from generation to generation, if we plot the trend, we see there's a 2.6 year-on-year growth in terms of the energy consumed. And if we extrapolate that out to 2030, what we see is that we're hitting 20 gigawatts of power for a single new generation frontier model. So ChatGPT 7 or Gemini 8 or whatever your model of choice is, by 2030, the kind of level of power required to train that model will be of the order of the output of 20 nuclear power plants. So massive, massive power demand for a new application that's really coming along recently. So why is that a problem for us? Can we outsource that to the US? Can we outsource that to China, like we do with manufacturing or other energy intensive processes? The answer is kind of a geopolitical question. So sovereign AI is a kind of concept that comes out of the geopolitical AI competition. And what it means is to essentially be AI that is developed and deployed using a country's own infrastructure, data and talent to advance innovation and strategic goals. So the ambition to not just be an AI taker, but a maker of AI as well, to have that domestic capability, to have national AI champions like Mistral, the French AI company that's been heavily supported by French government as a strategic priority. And what we've seen in the UK is that they've announced a £500 million sovereign AI fund in order to develop that capability. However, sovereign AI extends to the electrons that you use to power your data centers as well. There's no point pursuing strategic autonomy if your ability to use AI or train AI can be cut off by your dependence on vulnerable fossil fuel supply chains. So this leads us to the energy sector, the electricity system, where at all times we have to balance supply and demand. And what we're doing in the UK, in Great Britain, is moving towards a renewable-based grid. So what you're seeing here is the generation profile for the 1st of January 2025. And if we look under the hood, we'll see how that actually was made, or how that was actually met. So just looking at one 30-minute slice of the generation profile, we see the massive amount of complexity that's happening there. So more than 600 individual generation units are required to be coordinated by the system operator in order to just meet that half hour of demand. And that happens 48 times a day, 365 times a year. So our sovereign AI strategy is dependent on the functioning of a system that is becoming more complex to coordinate and to balance as well in real time. So while it's great that we're moving towards this renewable dominated system that will help us get off the supply of fossil fuels, the reality is this is increasing the complexity and the uncertainty in the system and bringing new challenges to operators. So the tool that operators use to manage this complexity is electricity markets. This is the way that we solve the kind of puzzle of trying to match demand and generation in real time. So speaking very broadly or very generally, the UK has two electricity markets. Day-ahead market, which is based on forecasts, settled 24 hours in advance, has high volume of power and lower average price. And then we have the balancing market, which is the short-term market. So this compensates for errors in the forecasts of the day-ahead market. And here we see there's a much lower volume. There's about 10% of the volume, and then there's a much higher average price. And it's also very prone to extreme prices. So this is the current setup of the electricity markets. This is how we kind of manage that complexity around it. And if we look at the balancing market, this is the short-term market over a number of years. What it tells you, or what it gives you, is an insight into the state of the system. So you might think of a market, people buying and selling, but the reality is electricity markets are information and data exchanges. Because of the ephemeral nature of electricity, it has to be consumed as soon as it's generated. You can't really store it in significant quantities yet. You have to have this real-time matching capability. And so our sense of uncertainty peaks in 2021, which is during COVID, and that was the highest point of uncertainty in the system. And as we're seeing, this is growing and growing and growing over the last few years. And the impact of sovereign AI, or the impact of the data centers required to deliver sovereign AI, is going to be many times greater than this. It's an entirely new challenge for the grid. So what do we do? So markets are part of the power system puzzle, but there are four broad categories that operators use of tasks that the operator has to perform to get the system to work. These are forecasting, scheduling, optimization, and predictive maintenance. And the reality is that today, these are all delivered by algorithms. And the structure of the market is determined by the function or capability of those algorithms. So the reason we have a day-ahead market is because we can resolve that market, we can solve all those bids and offers. It takes quite a bit of time, and the optimization algorithm has to run for a while, and we can only do that once in a day. So what we need to do is to develop a electricity system that is as intelligent as the models that it's used to train. We need to incorporate AI into these algorithms to upgrade them for the needs of the grid as it is now. And if we do this, we can also start to rethink the structure of electricity markets. So if we take a very simplified example, if we have perfect foresight, if we have better forecasting to perfectly perform our day-ahead forecasts, we get rid of the balancing market, which is the most expensive part of the entire system. So again, that's an extremis, but the way the market is structured right now is based on the performance of these algorithms. So if we can improve their performance, we can also think about how we restructure the electricity markets. And finally, there are challenges associated with applying AI in the power sector that are unique to the power sector. A power sector infrastructure is critical infrastructure. So decisions have high consequences and high cost if they go wrong. So we need to be able to explain how decisions are made. And this is not really where the state of AI is at the moment. And we need models that are both powerful and explainable so that decisions can be trusted and relied upon and also defended, essentially. So our work at the Bartlett is focused on that exact intersection, building transparent AI-driven systems that will allow us to achieve energy security and sovereign intelligence in tandem. So to wrap up, sovereign AI extends to the electrons that are used to power your data center. You cannot have sovereign AI without energy security. And the key to achieving that is upgrading the way the power system operates to incorporate AI. And what that will allow us to do is then rethink how we use markets, which are systems of data and information exchange. But with new capabilities, we can rethink how they all work together and bring transformational change to reimagine the nature of electricity markets. Thank you.